So logarithms, as I said, John Napier is the Scottish mathematician that came up with some of the stuff we talk about with logarithms. He's not necessarily a big name in math, but he's an important figure. I believe it is pronounced, Napier. And so with logarithms, the first thing we need to realize, and there's actually a few things here. If y is equal to a to the power x, this is like in an exponential form, then the log base a of y is x. Now, let's use this example to bring it back. If 9 is 3 squared, that means log base 3 of 9 is 2. That's the way you would say it. Now, this might sound like Greek, but as we use it, it will become more and more like English. So, the way I look at it is if I have log base 3 of 9 is 2, this is a secret of what I do. I just say that this raised to the power of that equal to that. So just remember that circle, that this raised to the power of that is equal to that. So this is why it's 3 squared is equal to 9. Okay, so that is how logarithms work. That's the beginning of the discussion of logarithms. The logarithm of 0 is undefined, so that is just a quick note that they mentioned here. Let me see a few more examples we can give you. Okay, so basically you can convert from the exponential form to the log form. So that is one skill that you just need to have. And how do you convert from one form to the other? As I said, if I give you the log form of something, then I tell you to convert it to the exponential form, you take the base here, raise it to that number on the other side, and set it equal to this number. So it'll be 4 squared is equal to 16. So you can even use a setup that you know. You know this. Now you just need to then say, okay, how do I make this into the log form, right? Because 4 squared is 16. That means log base 4 with 16 right next to it has the power. So it's like log base equals power. So that the base raised to the power is equal to some answer. That's the way I do it. That's basically what we're doing with logarithms. Okay, so what are some other rules of logarithms that we should be aware of? Or what are some other things? Well, let's try an example of using logarithms in a problem. So if somebody says 2 to the third is equal to 8. If someone says write that in log form, what you do then is, remember, we have a setup that we've used, right? So you say to yourself, that's my base, so that's going to be the 2. So it's going to be log of 2, right? And this number is always going to come there, is equal to my power, which is 3. I just wrote the exponential to the log form. So that's a good skill. Now what happens when we start introducing unknowns? So if someone says log base 3 of x is equal to -4. You see how it now becomes a little bit algebraic? We do the same thing. 3 raised to the power -4 is equal to x. So then, rules of exponents. Do you see why math builds? There's no way around it. So now a kid looks at this and says, what do? You go back to rule number whatever we said it was. And that is 1/3 to the 4th. So what is 1/3 to the 4th? So 3 times 3 times 3 times 3, and that's 1/81. That means that x is equal to 1/81. So we went from logarithms, and we found ourselves in rules of exponents, and they helped us solve the answer. And that's kind of the nature of math, is that sometimes somebody invented or discovered a topic, and it helps other people in their topics. So, okay, let's try a few more examples, and then we'll pause from logarithms. So what we're doing now is, what do we do when we have unknowns? So then what about log base 2 of 16 is equal to x? That means that we basically say 2 to the power x is equal to 16. Now, in math, when you have a number like 2 raised to the power of something is equal to a number that is a multiple of 2, it might be a good idea to then say, can I change this to 2 to the power of something? And yes, I can. It's 2 to the power 4. So 2 to the power x is equal to 2 to the power 4. Therefore, x has to be 4. And that's a rule, right? X to the m is equal to x to the n means that m is equal to n in this general situation that we're looking at. If the bases are the same, the powers have to be the same. So that's what happened over here. log base 2 of 16 is equal to x, became 2 to the power x is equal to 16. 2 to the power x just stayed the same. 16 became 2 to the 4th power. Because the 2's are the same base, the powers must be the same. That's another rule that we use with logarithms. Okay? So, what I'm going to do now is I'm actually going to list the rules of logarithms, and then I'll give you guys time to maybe try a few practice problems of what we just discussed. So let's go to the rules of logarithms. Here are the rules. Number 1. So rules of logarithms. Number 1. As far as skills, we already discussed how to convert from log to exponential, exponential to log. Again, we have practice here. But the first rule says if you have log base a of a times b, then this is the same thing as log base a of a plus log base a of b. So if there's a value, and I'll give you an example of that over here. But let me write down 3 rules, and then I'll give you examples of each. So that's the first rule. The second rule is if you have log base a of a over b, then you can subtract them. So it'll be log base a of a minus log base a of b. And the third rule is if you have log base a of a to the n, it is the same thing as n log base a of a. So those are 3 rules that will govern our work. Now, let's use examples for each one of them, right? Well, isn't that fair? Let's try it out with a problem, right? Remember, this is our goal, pre-calculus. I'm going to hide this down here. So our goal is to get done with college algebra, and then we'll do the pre-calc one. So we can do both of them by May. That's my dream. Okay, so we have, now keep in mind, this is in pre-calculus. So even though we're doing college algebra, we're doing pre-calculus at the same time. It's the same stuff. So here's the example here. If somebody says log base 5 of 12, and you're like, wait, what do I do with that? Well, the good news is that you can change this to log base 5 of 3 times 4. Because 3 times 4 is 12. Which is the same thing as log base 5 of 3 plus log base 5 of 4. That's how you simplify that problem. You took the 12, you broke it down, and then you used this rule to write it like that. So that's the answer. What if somebody says log base 7 of 14 over 3? Well, actually, of 7 over 3. Let's do that. Now, I will warn you, I'm about to do something which is not bad, it's just that I'm going to introduce a new concept within the example. I think you guys can handle it. But pay close attention, something's going to happen here. This is the same as log base 7 of 7 minus log base 7 of 3. When your base matches this number, this whole thing becomes 1. Beautiful, mind blown, right? So this becomes 1 minus log base 7 to the 3. That's the answer to that problem. The last example is if someone says log base 2 of 3 to the 4th power, that becomes 4 times log base 2 of 3. We just bring the 4 to the front. That's what the rule says. The rule says if you have a log with something up as a power, that 4 can come to the front, and that's how you deal with that log. We'll take a break and do some practice problems.